In software engineering, coupling is how much one piece of code depends on another piece of code. For example, if object A needs object B in order to work, then A is coupled to B. Some coupling is unavoidable. Software components must interact. That is the point of a system. But the real issue is how much they depend on each other's details. Imagine two parts of a system, an inventory service and an order service. If the order service needs to know the exact database tables used by the inventory system, how stock quantities are calculated internally, the internal functions used to reserve items, then those components are tightly coupled. But if the order service simply says, reserve 1 unit of this product, and the inventory service replies, reserved or out of stock, now the order service doesn't care how stock is tracked, how warehouses are managed, how inventory calculation is done. It only cares that the items is reserved, and suddenly the two systems can evolve independently. Let's zoom out for a second. Why does this matter so much? Well, because software systems never stay still. Requirements change, team change, technology changes. The real question isn't, does the system work today? The real question is, what happens when it needs to change? Let me give you another scenario. Think of a restaurant. The customer places an order. The waiter carries the request. The kitchen prepares the food. Now imagine the customer walking into the kitchen to rearrange the cooking process. There will be chaos, right? The system works because each row interacts through clear interfaces. Customers don't need to know cooking techniques. The kitchen doesn't need to know how customer settings are arranged. Loose coupling works the same way. Objects communicate through defined contracts, not internal details. So how do we actually achieve loose coupling? I will mention a few. 1. Interfaces. Instead of depending on concrete implementations, depend on interfaces. This means an object says, I don't care how you do it, just follow this contract. This allows implementations to change without affecting the rest of the system. 2. Dependency injection. Instead of creating dependencies inside the class, you pass them in. This allows you to swap components easily. Testing becomes easier. Changing implementations becomes easier. And your system becomes more flexible.